So my name is Jeff Tollaksen, and I'm a professor of physics here at Chapman University, and I'm also a co-director of an institute. It's called the Institute for Quantum Studies. That's based here at Chapman University. Your question is asking about theoretical idea in physics. Comes by different names. Sometimes they call it multiverse. So there's another version of the theory they call many worlds. But these theories were developed to try to answer another one of these really big why questions, these big philosophical questions. So why is it, if it's a random process, that we just happen to find ourselves in a world that is very friendly towards life and biology in general? How is that possible?
My name is Cai Waegell. I'm a research scientist in the Institute for Quantum Studies here at Chapman University. I study the foundations of quantum mechanics and interpretations of quantum mechanics. It's actually several different concepts. There are a few different notions of what a multiverse could be. These are ideas where you could have completely separate universes from our own that might have entirely different laws of physics and really wouldn't work anything like our universe. Another relatively prevalent notion has to do with the many worlds interpretation of quantum mechanics. In the many worlds interpretation, as quantum events are taking place, the world that we exist in is branching into distinct worlds. But at our macroscopic scale, we're never aware of the other worlds that are there. In all of these cases, at our macroscopic scale, our best ideas now are that if there are multiverses, they won't affect us at all. They'll do their thing and we'll do our thing.
The two universes are so like water and oil, they so don't mix, that even attempting to make them connect with each other would completely annihilate both universes. You don't have a situation like Lenny Susskind was talking about, where you have 10 to the 1,000 universes, right? But you have a situation that the universes that actually come into existence, it's a kind of a co-creation phenomena, because there's a kind of a loop, a huge loop in time, this co-participation. It's not just the case that we exist in this one little window of time that we usually experience. Our usual conscious experience, we think we just exist in this one moment in time, but actually it's far more interesting than that.
The theory predicts that there are particular configurations of matter which can warp space-time so much that you can create a loop that goes from a point in the future back around to a point in the past. But to engineer those kinds of, the kinds of masses that we would need to do that is far, far beyond our technological capability. Even if it does happen, the theory really doesn't tell us exactly what the rules of time travel would be. There are a number of different speculations about how that might work. Nature is probably structured in such a way that it prevents paradoxes from occurring. So suppose that you did this and went back in time. You might encounter sort of the classic grandfather paradox. They explored it in Back to the Future. So you go back and somehow prevent your parents from conceiving you, and then you're not born. And then how could you have gone back and done that in the first place? So that creates a causal paradox. In Back to the Future, the way that the universe tries to fix it is sort of to slowly erase the character who did it from existence. But that's just a purely speculative, fun thing they did for the sake of the movie, where Marty McFly is slowly disappearing and is trying to stop himself from ceasing to exist by undoing the paradox that he inadvertently created.
I certainly appreciate the creativity in these solutions. The problem still remains. It's an immensely profound question. Why are we here? For one universe to interact with another universe, they would just blow each other up. You wouldn't even have time to write the results of the experiment, right? So is that doing science when you can't test the theory? So Interstellar is probably one of those few movies that really did stay as close as possible to what we know to be true about physics. Sometimes you see movies which are using that version. Some movies which use multiverse, some use movies that use the many worlds theory. The multiverse theory is much more plausible, as implausible as it is, right? The many worlds theory, one way of describing it is economical in axioms but expensive in universes. If you really believed in a many worlds theory, maybe people would say that, why should I have any morality? Like, why don't I just go rob a bank or something? Then I know that there will be some worlds in which I'm successful and other worlds which I'm not successful. But as long as there's some worlds where I was successful, why wouldn't I do such a horrific thing?
The stuff that's in movies is very far removed from what's actually been done in experiments. So I'm a big fan of science fiction. I like these ideas. Really, aside from actual physics, I think that science fiction is a vehicle for taking human beings, putting them in an unusual circumstance, and then really telling a story about their humanity in that circumstance. So the science fiction is kind of just a backdrop. It creates a setting where you can ask unusual questions about how people would react to unusual situations. So I mean, I like these movies. I think that, you know, they're a lot of fun. I've read some of the books too. They have a positive effect, which is that they do inspire people to be curious about science, but they're mostly very, very speculative, and they really don't make any effort to be consistent with the science we know. Again, from a science fiction standpoint, that's not a bad way to go. I don't think science fiction really needs to be rooted in real science necessarily. If you want to tell a story about people, you can kind of imagine any bizarre scenario that you can put them in. And so the multiverses, time travel, things like that, they've been vehicles to tell really interesting stories. But I think the movies that are out there, they don't really have much to do with actual physics.